Pump curves are everywhere in engineering. We see them in catalogs, data sheets, and selection software. But most engineers are never told what pump curves actually hide. Pump curves are correct, but real systems rarely behave the way engineers expect them to. The common belief is simple. If my duty point lies on the pump curve, the pump should deliver that flow and pressure. On paper, that logic makes sense. But once the pump is installed on site, reality looks very different. Actual flow and pressure almost never match the curve. This is not because the pump is faulty, it's because the pump curve is only half the story. Pump curves are generated under controlled laboratory conditions. They are tested with water at a fixed speed, under ideal conditions. The curve shows what the pump can do, not what your system will allow it to do. What pump curves don't tell you is just as important. They don't account for fluid viscosity, they don't account for temperature changes, and they don't account for real piping losses, fittings, valves, or fouling. This missing piece is the system curve. The system curve represents everything the pump is working against: pipe friction, elevation, valves, and flow resistance. The actual operating point is where the pump curve and the system curve intersect. That intersection decides the real flow and pressure. And here's the critical part. The pump curve stays the same, but the system curve keeps changing. When a valve throttles, the system curve shifts. When pipes foul, the system curve shifts. When temperature changes fluid properties, the system curve shifts. As the system curve moves, the operating point moves with it. This is why pumps appear to underperform on site. But pumps don't underperform. Expectations do. Engineers expect the pump to behave exactly like the catalog curve, without accounting for how the system actually behaves. Misunderstanding pump curves often leads to oversizing. Bigger pumps are selected just to be safe. Then valves are throttled to control flow. The result is wasted energy, higher operating costs, and unnecessary stress on seals and bearings, all because the system was misunderstood. So what should engineers do differently? Always consider the system curve, not just the pump curve. Always check fluid properties like viscosity and temperature, and always expect the operating point to shift during real operation. Pump curves don't lie, they just don't tell the whole truth. If this video changed how you think about pump selection and performance, subscribe to Engineering Unfiltered. Real engineering, no filters.